Alright, this is Math 2, Unit 4, Lesson 4, looking at medians and altitudes today. Just to recall, a median is something that's going to bisect the line segment in half. An altitude is going to create a 90-degree angle when it touches the other side coming off of an angle. Okay, we'll get to more of that as we go along here. Let's look at the first thing. It says, we're looking at numbers 1, 7, 8, 11, 12, 14, 15, just as part of your homework tonight. Alright, if DZ equals 12, find ZA and AD. It tells us first of all that A is the centroid. Okay, what that's saying is that, let's say for example, DZ we know is 12, right? So DZ is equal to 12. If you remember from your lesson today in your class, what we're saying is we're going to take this segment and we're going to divide it into 3 parts. So 12 divided by 3 is 4. So let's take, for example, if this is DZ, written out this way, D and Z, and I break it up into 3 sections, so I have 1 and 2 and 3, each section would be equal to 4. Okay? I took my 12, divided it by 3, and I have 3 equal sections of 4. Because A is the centroid, I'll make this A right here, that's my centroid. What that tells me is that this part is 1/3 of the length, and this section over here, A to Z, is 2/3 of the length of the whole thing. You follow me here? So I have 1/3, my DA is 1/3, but my AZ is 2/3. Combined, it makes up the whole thing. So ZA, in this case number 1, is equal to, if the whole thing is DZ, it's equal to 2/3 of DZ. So this length is 2/3 of DZ. And I can use that essentially as a formula and equation to figure out what the line lengths are going to be. And that's what it's wanting you to do here. It says, alright, so let's find ZA and AD. Well, ZA we already decided was 2 of these parts, so it's 4 plus 4. ZA is going to be 8, and AD is going to be equal to just one of them, 4. So it depends on how you want to look at that. Again, I'm starting with the number 12. I could take 12 and I could, divide it by, or multiply it by 2/3 and get that answer there. I can multiply it by 1/3 and get the AD. Up to you how you want to look at that. But that's essentially what we're looking at here. So ZA, we said, is equal to 2/3 of DZ. So let's go ahead and plug it back in real quick for those of you who want to see that. I would say 2/3 times 12, just to solve for ZA. We already said the answer is 8, so I know what I'm working towards here. Oh, sorry about that. Blocked it off for you. So ZA equals 2/3 of DZ. So I plug in DZ as 12. Well, I can reduce 12 over 1. I can reduce here. 3 goes into 12 4 times. So I can reduce that and multiply across. 4 times 2 is 8. If you're not good at reducing, you forgot how a little bit with your fractions, 2/3 times 12, I could do it the long way and just multiply it. 12 times 2 is 24, and then 3 on the bottom, but 24 divided by 3 is still going to be equal to 8. So that's just the long way of doing the mathematics there. Okay, let's look down here at number, well, just remember, MN is a median, and altitude, to try and decide a median, also median, remember, cuts it in half. Altitude makes that 90-degree angle here. So as you're looking at these things, you're just supposed to decide, is it a median or is it an altitude? Looks like it's dealing with an angle right there. Looks like it's dealing with a 90-degree angle right there. Let you figure that part out there. So let's look at number 7. 7 says, what is a median in STU? Here's my STU, my entire triangle there. I'm looking for something to cut something in half. When I look at some half segments here, I have a choice. I could say that, well, this is a half point there. So this line from an A has to come from angle S all the way down to B, cuts it in half. So I would say that SB is a median. I'm not going to use this one. I know those are two equal parts, but see CB, it's not coming off of an angle, so that's not going to work there. I can't use CB. It has to come off of an angle. For an altitude, I want a 90 degree. So I'm looking at what comes off an angle makes a 90. Does that make a 90? Nope. And this one doesn't go anywhere, so no. So I'm left with this one. It goes down. There's my 90. So I would say either AU or UA, it doesn't matter, and is my altitude. There's a couple examples there. Number 11 I thought was a really good problem, kind of fun. Again, you have to like some fun math stuff, I guess. So it says that Q is the centroid of JKL. That's telling me that I'm going to get one of these 2/3, 1/3 kind of deals, right? And that PK, this whole length, is equal to 9x plus 21y. Okay? Now notice the numbers they gave you. Can you think of a number that goes into 9 and 21? I'm going to go with maybe 3. Because if you remember back before, back at the top, we were taking our number and we were dividing into 3 sections. So here's a fun way of thinking about this problem. Let's say I want to think about, because I want to find out what PQ is and QK. If I look at this, I can see PQ is going to be my smaller section. That's the 1/3. And the QK is my larger section, the 2/3. Okay? I'm going to take my 9x and let's see if I can break it into 3 equal parts. Like, let's say, for example, a 3x and a 3x and a 3x. If I add those together, I get a 9x, correct? Yeah, so that's good. So if I take my x part and break it up, I can have 3x, 3x, 3x. I can do the same thing with 21. I could break that up into a 7y and a 7y and a 7y, because 7 plus 7 plus 7 is 21. Now watch this. This is kind of fun for me. I'm going to go ahead and draw a line right here, and I have 2/3 and 2/3. Well, my bigger section is the QK. QK gets 2/3 of all this stuff, and PQ only gets 1/3 of it. So what does QK actually get? It gets 3x plus 3x, which is a total of 6x, and it gets 7y plus 7y, which is a total of 14y. So QK equals 6x plus 14y. PQ gets what's left, equals 3x plus 7y. And there's that part. Does that kind of make sense? Well, all I did is I took this part here and I broke it into thirds and said one of you gets 2/3, the other one gets 1/3. And that's all you're doing in there. I don't know. I thought that was kind of fun. Alright, looking on the back side here, I want you to find the orthocenter of each triangle. Remember, the orthocenter is where the altitudes meet. And an altitude is coming off of an angle and forming that 90 degree. So if I look here, this line is coming here, making a 90 degree. So I'm looking at that line. This line comes down and makes a 90 degree. This one right here is irrelevant. It's not making a 90 degree. I don't care. This one right here, irrelevant. Not making a 90 degree. I don't care. So the place where these come together and make a 90 degree is right here where they meet, and that is point H for number 12. So just don't get distracted by the other lines. You have to ask yourself, where do my altitudes meet at? And they meet right there at point H. I know I covered over my H with my circle. Sorry about that. Number 14. Same kind of idea, except now we're going to have to do some graphing and some plotting to figure some things out. Alright. So, they already have a triangle here for us. I'm going to darken mine up for you so you can see a little bit better, because mine's not very dark on my copy. So I have this charming triangle. ABC, ABC. Alright. And what I want to do is find the orthocenter. Now, this triangle, because it's not a 90-degree triangle, my orthocenter will be somewhere inside of the triangle. I have an acute triangle, so it's going to be in the middle somewhere. Alright? One of the ways of doing this here is, because I need to form a 90-degree angle coming from the opposite angle, so let's say from B, I'm going to draw a line that makes a 90-degree angle over here. In order to do that, a 90-degree angle is going to be formed by two lines that have that opposite slope. So let's say, for example, AC. AC, let's start there, has a slope of, think about rise over run, it goes down 2 over 1. So we're going to go down 2 over 1. We'll try it again, down 2 over 1, down 2 over 1, yep, that's it. So my slope for AC is negative 2 over 1, which means if I'm going to flip this around and then change it from positive to negative, what I'm looking for is coming off of angle B. I want a slope off of angle B that's going to be the opposite of that, which would be 1 over 2. You see how 1 over 2 is the opposite of negative 2 over 1? Yeah, inverse reciprocal. So I take the 2, put it on the bottom, put the 1, put it on the top, and make it negative instead of positive, or positive instead of negative. So here's what I do here. Just going to plot it out. I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. Okay. How are we doing so far? Doing all right? I have a little line there, a little line there, a little line there. You can see it's not going to quite make a point here. I go up 1 over 2. I'm going to go to there. So it's still a line. We're still in good shape. And I can come back here with my pencil and I can draw my first little line. And my first altitude is going to be right there. But I'm not worried about an altitude here. I'm looking for the orthocenter, right? So I'm looking for where these other ones are going to cross it as well. So I'll do the same thing. I have a BA. All right, BA. The slope of BA goes up 2 over 1, up 2 over 1. So my slope of BA is 2, 1. Which means, if I want to find the angle opposite of BA, I'm going to look at C. For angle C, I'm going to flip that around. I'm going to go, let's think about this one here. Opposite, 1 over 2, and down 1 over 2. Now this one's a little funky because you look at where we are. If I go down 1 over 2, I'm off the chart. So I need to do a little bit backwards here, don't I? I'm actually going to go up 1 and then the other way over 2, up 1 over 2, and you can see I've already got a place where I'm meeting up here, and then up 1 over 2 here, because I'm working backwards. Alright, so we draw that line there. We can already kind of guess, I think that might be Orthocenter, but let's double check. This one's not as bad because it's not a slope. We're just going to be going straight across, right? We have a slope here. If you think about your slope, we're going up 1. Nope, up nowhere. Just going to go up to 0. So for BC, we have what? We have up to 0 over 1. Doesn't quite work, does it? So because of that, we're just having this one's going to go across horizontally. I look at A, we're going to just come down vertically. And that makes that nice point right there. So my orthocenter is going to be where all those lines converge together, which is right here. So to find that point, I look and see my x value is 6. My y value is 4. And that's my orthocenter for that shape right there. I do want to do number 15 with you as well. I'm not going to do 16. 16 is going to be, you'll form a triangle and you'll make a triangle. It's going to be acute, which means the orthocenter will be in the center. I do want to do 15 with you just so we're on the same page here. It does want you to first of all plot the points out. So I have a point at 1, 7, which is here. That's my point P. I have 1, 2. That's my point Q. And then I have 11 way over here, 2, which is my R value. Now when I draw this one out, what you'll notice right away is that I have a right angled triangle. As a result, that means my orthocenter is not going to be on the inside, it's going to be on the outside, and it's actually going to be on the hypotenuse, which means, it's kind of a nice thing for you actually, it means I only need to find one line that forms a right angle right here. That's what I'm trying to find for you. So what I'll do is I'll look at the slope of PR. PR has a slope of down 1 over 2, down 1 over 2, down 1 over 2. So my slope of PR is down 1 over 2. If I flip that whole thing around to get my slope for coming off of Q, I get 2 over 1. Follow me there? Just flipped it around. So when I flip off of Q, I'm going to go up 2 over 1, up 2 over 1. And I can see I end up right there at that point. And I can draw my real line this time. And I end up at point 3, comma 6. And that's my orthocenter. Okay? And that's all there is to it. Alright. Well, good luck on those other ones. Hope you do alright there. I think I did something not quite right. I'm looking at my answers. The answer here is 1, comma 2. Oh. I'm going to pause real quick. Interesting. Okay, so my answer key says the answer should be 1, comma 2. Looks like I messed something up there. I'm not quite sure. Well, let's see. If I look at this line, my slope would be positive. 1, comma 2 would be 1, comma 2. Yeah, that doesn't seem right. I'm not sure. I end up with 3, 6. But maybe there's something different. I'm not sure. I'll leave it at that for now. I'll write a question mark right here, and I'll say I'm not sure. The answer key says this, which should put it right here at point 1 and 2 at point Q as the orthocenter, which doesn't make sense for a vertex to be the orthocenter of the whole thing, but maybe there's a reason for that. I'm not sure. As you're working on number 16, I'll let you work on that on your own. You're going to be aiming at getting the answer key here says 5, comma 8 is where you're going to be aiming for number 16. So, sorry about that one. Not sure what happened there. Ask your teacher and see what I did wrong.